Okay, guys, I'm going to get started here. Great. So to set expectations today, I'm going to be talking about SLA technology. SLA is a type of 3D printing technology. And so first I'll explain what that is. Then I'll go over why you should choose or consider SLA technology, its applications, some case studies. After that, I'm going to talk about the UnionTech printers themselves, and then I'm going to demo the software. I'll spend about 15 minutes showing you the software. It's really easy. And then last, I'll talk about next steps if you want to bring this technology in-house, what it takes, and how to contact us to move forward. Okay. So what is SLA technology? Sometimes it's called SL or SLA. So it's stereolithography. The A at the end is for aperture, and you'll see them used interchangeably. So if you hear either one, they mean the same thing. And so what it is it's a type of technology that will slowly build your 3D CAD files into a real object. This technology for 3D printing uses a laser to cure at specific locations a vat of resin to build your part. So it's the resin is a photopolymer that's cured by the laser. If we look over on the right-hand side here, what we can see is this black box here would be the laser itself. The red is just, you don't actually see the laser. It's not a red beam, but the laser will shoot out and it will hit a scanning system, which is just a set of mirrors that determine where that laser should hit the vat of resin. And wherever that scanning system moves that laser is where that laser is going to cure and start building your parts. Next, we have a vat, and the vat just holds whatever type of resin you put in. So there's about 12 different resins, and you can choose based on what resin's best for you, and then the vat will hold it. Down below here, we'll have, this is a representation of the 3D printed part that's being printed. Each one of those little lines is called like a layer or a step between building your parts. And here's a kind of a close-up of it. So this is a picture of the side of the SLA printer. Here's another detailed view of it. So we'd have a laser, the scanning system, which just is a mirror that moves to adjust where that laser should hit. We have the solidified resin right here, and then we have the platform that moves down and the resin around it. So what is really fantastic about this technology is that there's not many moving parts. Everyone wants reliability, and if you can imagine, less moving parts means more reliable. So what we have that moves is basically the scanner system, which moves the mirror, and the platform that goes up and down. That's about all that moves. So once you get it set up and leveled, so you level the scanning system, you adjust the scanning system, and you level the platform to the resin, and then that's about it. It's very reliable. There's not many moving parts. That's one of the things I really like about it. This technology has been around since the 80s, and so it's been really vetted, and they've worked out a lot of the kinks. So that's kind of a quick overview of what SLA is. Next, I'm going to talk about why you would choose the SL technology over other ones. So the main benefits of SL technology is the versatility. So when I was talking about there's 12 different materials of resin, and each one of these resins has different material properties, and they're for a different end use. So you have things that you could print almost like a rubber or a sponge type material for a flexible, all the way up to a very rigid material. You also have the ability to print a clear material and some very high temperature materials, so up to 260 C. So those are a lot of different options you have. The other thing I like is that it's isotropic performance. So the way the laser, as it's curing each layer, it actually penetrates a little deeper than just whatever layer thickness it is. So if you're printing at, let's say 100 microns, it will penetrate about maybe 120, and the reason it does that is so it actually bonds the previous layer. So you have when we talk about isotropic strength, if you pull in an X, Y, or Z, you want all those to yield or fail at the same amount of pressure or force. And some other technologies do not have that. One direction, which is usually the Z, is quite a bit weaker. And that's something that the SLA excels at, is having an isometric performance. Also, because it's a laser and the very small spot size for the laser, you have very high accuracy. So you can make very, very detailed parts that mimic injection molding parts and smooth surfaces. So let's say that you're a company and you need to build what looks like an injection molded part for a meeting or for a prototype to assemble and then test and give to users, so they wouldn't know that it's a prototype. You want them to think it's an end-use part. An SLA printer would be a perfect application. And the other thing is this material is stable. So if you need the part for 6 weeks or a year, it's a very stable material. Okay, so applications. Who's using this and why would they use it? Obviously, the first people that would use this material are anyone that does rapid prototyping. So if you're in your company and you're making products, this would be a great thing to integrate into your company so you can cut down your production cycle. Another different industry would be automotive. Shoemakers. So a lot of times in shoemaking, you have many different ideas for treads of the bottom of the shoe, or different ideas of how you want the colors or the shapes or the materials. So you can print many different iterations and bring them to meetings and talk about these things. Of course, art, since it's a high resolution printer, you can have very, very detailed parts. In many movies, a lot of the 3D printed parts or 3D printed things, like from Iron Man, are all 3D printed on an SLA printer because of the high resolution, and it looks like an end-use part. In medical, there's tons of uses for medical. And last, of course, for education. So you would be able to print out things. When you hand a child a model, it gets their interest a lot more than just having them look at a piece of paper or a book. So you can make physical models that kids can touch and feel and get much, much more interesting. They'll find it much more interesting. Okay, with that in mind, so some of the applications, one of the great things about the SLA printers or SL printers is how large the build volume can get. So you can, with that in mind, you can get the smallest one. The smallest SLA printer that UnionTech sells is a 10 by 10 by 10. Usually that's bigger than most 3D printers that you buy. Most of them are even smaller than that. That's their small side, is 10 by 10. And you can go up to a printer that's 64 inches long. And that's fantastic for anyone that needs to make really big parts that are accurate. You don't have to cut up your model and glue a bunch of things together. You could just print one big part or many different smaller parts within the build table. Again, there's a wide range of materials. There's about 12 different materials just from one company called Somos. It's great for concept models, investment casting, urethane casting, clear parts, functional prototypes, end-use parts. And this last one is really cool. You can actually metal coat parts. So if you can't afford a metal printer, which many people can't afford one of those, you could get all the benefits of having an SLA printer, and then on the few times that you need a metal part, you could 3D print the SLA part and then metal coat it. So here's some applications. So I just took some different 3D printed parts that we have, and I ran some statistics so you can get an idea of the printed parts, the cost, its support material, and the time it costs to print. So this clear housing, a lot of times it's hard to print clear. Not many printers can do that. with this technology, you can. And so this clear cover here for this, actually this entire thing was printed with different resins, but the clear cover was printed with the water clear ultra. It's about a $32 part, and it took 9 hours to print. So what I tell most people is work during the day, set up your files, and then just hit print overnight. So when you come in the next day, your parts are done. And it makes it really exciting to come in the next day to work if you know that in your printer your part is done and you can start working on it. Here's another application for a housing. And this housing was printed with ABS type material. This was a simple $10 print, and it took about 14 hours to print both sides. What's great about this is, of course, this is for prototyping, so you can put all your different circuit boards and test it and assemble it and make sure it works and make sure it fits in the hand before you go to an injection mold. The next one here is really interesting. So maybe you want to actually print out the mold itself, and then you want to inject the real material. Well, you can do that. So with the Sonos Perform, you can actually 3D print the mold, and it's not going to last forever, but you may get 10, 100 shots, who knows. But what's fantastic about this is that you can print the mold, you can then inject the real material that you want to go to production with, and you can test that as well. And it didn't take that long to print either. It was only about 3 hours to print. If you needed to make another design change, this is how you could find that there's an error in your design way before you go to a real injection mold. Here's another example of for dentistry. So with this one, it was really simple print, but let's say that you needed to practice. You could practice, if you're a dentist, you could practice on this 3D printed jaw and set up how you're going to remove a tooth or how you're going to cut into the jaw before you practice on, or before you operate on the patient. And here's some companies that are actually using the SLA technology from UnionTech. So this one is just obviously simple prototypes for different fixtures. Here's another really cool one. So this company, they're actually making this. It's going to be a handheld washing machine, and this would be something that, you know, it would be really hard to validate that it works unless you 3D printed it. And of course, you wouldn't want to jump into making an injection mold until you have validated this process. Here's another one I really like. So, you know, with car design, the bumpers are very free-flowing and or organic shapes. Well, what if you wanted to then have that intake on the lower end to flow into your brakes so you have some brake cooling? Well, you can easily do that with an SLA printer. It doesn't really care about the geometry. So you can make these cooling ducts really easily. And here's another cool one for, let's say that you want a presentation to show someone a heart. This is a 3D printed heart here, and it's great to show patients. It's great to show other doctors, and then you could actually, if you needed to do something, you could experiment with this before operating on a patient. And here's my last example, and this is metal coating. So you can metal coat your parts. There's a company that specializes in this called Repliform. So you could bring a UnionTech printer in-house, you could 3D print your parts, and the ones that you need metal coated, you could send them off to Repliform to get metal coated. And surprisingly enough, this adds a lot of strength too. Okay, so I talked about what SLA is, or SL technology. I've talked about why you should choose SL, or why it would be beneficial for you, the applications, the case studies. Next, I'm going to talk about UnionTech printers themselves. So UnionTech has been around for many years. This is their mission statement, to innovate, integrate solutions, provider for additive manufacturing, and they have been around for a while. They have they have offices all over the world, and they also have printers all over the world. This is something else that's really cool. So a lot of companies, they just come out with a product and they just keep on selling that one product. UnionTech invests 15% of their revenue into R&D. So they're always trying to make their products better, which I have personally seen. I have requested different features to be added into the software, and about a week or two later, they were actually able to implement the features that I requested. And that's something that's really cool, that they care about making their software better, easier to use, and more reliable. Here's some examples of the companies that are using the UnionTech printers. And one thing that stands out from other 3D printers is the use of the granite. The granite, it's very dimensionally stable. It doesn't expand or contract. So as soon as you level everything to the granite, you level the resin and you level the platform to the granite, not much changes. And that's how you can hold very, very tight tolerances. The next thing that's really cool is they have a closed loop system for the resin. So if we look here, you can ensure within 0.03 millimeters of accuracy. And that's pretty outstanding. So when you're trying to 3D print and you want something to be as close as an injection mold or as close as the CAD model, this is a fantastic technology to use. And also the vacuum is a closed loop system too. So that means per layer it can adjust and always optimize per layer that you have the best print. The other thing that's really cool is UnionTech is an open source printer, so they don't care what material you put in it as long as it works. So any material that is the 355 nanometers material can be used. And this is how kind of a quick way to see the different materials. So I've broken it up into a general material, which is the Somos GP. Heat resistant, there's about 3 different heat resistant materials. So if you're just looking for a heat resistant material, you can actually dig down deeper than that and say, well, maybe I want one that's heat resistant and more stiff, or maybe I want one that's heat resistant and clear. There's different options within just heat resistance. There's a high ductility, there's transparent materials, and there's also colored materials. Their profile, the machine profile for UnionTech. What we have here is, this is their commercial series. And so with the commercial series, there's 2 different printers. On the left-hand side, we have the Pilot 250, and it's a 250 by 250 by 250 millimeter build volume, and that's 10 by 10 by 10. On the right-hand side, the bigger printer is 450, and that's 450 by 450 by 400, so that's 17.8 by 17.8 by 15 inches deep for the build volumes. That's a very large bat, which is really cool. A lot of other printers have smaller build volumes, and so you always have to cut off your model. You can't print big parts. If we go to the next slide here, with the production series, we get even larger printers. So with the RS Pro 600, it's 600 by 600 by 500. The RS Pro 800, as you can see, the names kind of make sense. It's 800 by 800 by 550, which is really cool. Really big build volumes for these. And again, you can use any one of those different materials. And so it just gives you a lot of different versatility. And this is the really exciting printer that should be out hopefully by the end of this year, and it has a huge build volume of 1400. So there's prototypes of this, and you can just print. Imagine if you're Ford or Chevy and you want to print a dash, and make sure that dash works before you go to an injection mold. You could print the entire dash as one piece, verify that it works before you ever go to injection molding. Because if you mess up when you make an injection mold, it's going to cost you a lot of money, it's going to cost a lot of time, and you may miss deadlines. So that's where these printers really shine. And you have the same resolution and accuracy. You can see you can go down to 100 microns or 0.1. So you have really thin layers, really accurate because it's a laser, not many moving parts, just a scanning system and the build platform that goes up and down. Okay, so I talked a little bit about the UnionTech printers. Now I'm going to talk about the software. So most people that are on this webinar probably use SOLIDWORKS, so I'm going to start in SOLIDWORKS and walk you through the whole process of setting up a build. So this is going to involve design. I already have a part designed in SOLIDWORKS. I'm going to show you how to export it, arrange it in PolyDivs, which is the software that you actually can purchase two different softwares, PolyDivs or Magix. I'm going to show PolyDivs, and I'm going to show you how to slice, build supports, and send it to the printer. So within SOLIDWORKS, I have this cover here that I want to print, and it's just a simple design, you know, maybe for like a Raspberry Pi. I just need to cover it. I need a spot for a USB drive to enter. And so how you do this is you have your part all finished, and you can go to File, Save As, and you choose either STL or 3MF. They're both 3D printable files. I would choose the 3MF. It's a smaller file. It has a more reliable algorithm, so when it does the conversion, it just works better. STL is a legacy file that we're slowly trying to move away from and move into this 3MF file. So you'd select that, and then go into the options here, and this is where one of the tips that I like to point out. You always want to export the units the same as what you're designing in. So down in the bottom right-hand corner, I can see I'm designing in millimeters. So I want to export also in millimeters, just so that there's no conversion. I also can adjust the resolution. And I've been talking this whole time about how high the resolution is on the SLA printers. Well, the last thing you want to do is send a very rough, coarse design to a very fine printer, because the limiting factor would be that SOLIDWORKS export. You want the limiting factor to be the printer, and so that you get the best results. And the printer is really a fantastically fine printer, so you want to give it the best data in, the best M3F. So to do that, I usually raise these up to about 90%. And then, so there's a couple options here that I really recommend unchecking. I don't need to know how big a file is, and I don't need a preview. Both those things just take time to process. If you're building a part in SOLIDWORKS, you already know what the part looks like. You just need the 3MF file. So I uncheck those. And then I'll just save it where I need to save it. I happen to already save it, so you'll see me save over this file. Okay, so let's look at that file in the directory here. So I have the SOLIDWORKS CAD file, and I saved it out in both formats just to show you the difference. So we have the cover design in the M3F, and then we have it in the legacy format of an STL. Something else to notice is the STL is quite a bit larger. So two bad things about STLs is they're a larger file size, and they're less likely to export correctly. A lot of times with STLs, you can get parts that are not watertight, and that just adds more confusion and more headache later down the line if you have to fix the STL. Where the benefit of the 3MF is at a smaller size, and the algorithm for making the conversion works better. So you have less problems down the road. So let me delete this out, and I'll show you the PolyDiv software. So if I zoom out, this is the PolyDev software. And the first thing I'm going to do is open up a part. So I'm going to open up that M3F file. And then it comes in, and the logic here is you open up, you don't always print with one part in the build. Maybe you print 4 or 5. So you would go to File, Open, grab all your different parts, and then you want to arrange them on the build table. So you can do that by going to Position, Arrange Parts, or Shift-A. And then it gives you this option, and I just hit Confirm. And there it's in the center of my build table. Nice and easy. The next thing is you want to think about how this is going to be printed, and if that's the way you want to print it, this orientation. I would not print it this way because there would be a lot of supports within the part that you'd have to break off, and that'd be more work. I want to minimize any of my post-processing time. So let me show you what I mean. This is not the way I do it, but you can go to Supports, and I'll just use Quick Supports for this one. And it's going to generate the supports. It does it really quickly, as you're going to see here. And there we go. So this is not the way I recommend it, but I want to show you the bad way first so you can understand this. Look at all these supports in here. That would take a long time to break all those off, and that wouldn't be fun. I want to minimize my post-processing time, so don't do it this way. When all you'd have to do is a simple rotation, and you would have a lot less post-processing. So I hit R for rotate. I can simply rotate this part around, and you can see I'm going to just rotate it like this, 270 degrees. I hit Confirm. So how it builds supports is it's basically wherever there's a shadow. So if this part's casting a shadow onto the build table, that's where it's going to build the supports. So it's going to build supports underneath this, but there's going to be no supports within this, the inside of my part where I want to put the Raspberry Pi. So I'll hit Quick Supports again, and I'll build the supports. And now if we look at it this time, there's not many supports being made, and this is going to be a lot easier to post-process. So for this one, this is how I would print it. Also, if I wanted to smooth out that surface at the end, since it's a planar flat surface, just using some very fine 600 grit sandpaper, wet sand that would be nice and smooth and easy to do. So that's building the supports. The next thing is I want to slice it. So that's the second to last step before you send it to the printer is you slice it. Within the slicing, you can also say send to the printer. So it's called slicing or Shift-E. Within this, you can choose your layer thickness. So let's say I want to print it, this would be 100 microns. I want to print it actually at 50 microns. I could select all parts or just some of the parts. I could export this file. So let's say that your printer is not connected to the network. You're using a thumb drive. You can use this export one. There's also another cool feature here, which is an adaptive slice. So what that means is you could say for some of the part, I want it to be 50 micron slicing. And for some of it, I want it to be 150 micron slicing. What that would do is you would consider doing this as if some of your parts are very vertical and you want that part to print really fast and you don't care about the resolution. But then at another part, you want it to be very high resolution because it's a lot of organic shapes. You could adjust the height for that. Some really cool stuff. I don't need to use that for this print. I just hit start, and it's going to slice my part. If I was connected to the printer, it would send it straight to a UnionTech printer, and I would be done. I also get this preview here. So with this preview, I can go and I can see each layer. So these are my supports. And then as I go up, I can see that it goes into my part. And this is just a nice way for me to interrogate the build. So here's my part, here's the slicing, and that's about it for the software. It's really easy to use. If you've used SolidWorks, the learning curve is so easy. It's maybe a half a day. I mean, training is really easy as well. Okay, So going back to the webinar, so that was PolyDesk. Next thing I'm going to show you is a quick video from Magix. So Magix is another software you can use, and it uses an even smarter algorithm for its support. And that's why I wanted to show this as well. So when you're done building, that's what it looks like when it raises the part out of the resin. And so this is what you do when it's done printing. You need to wear gloves because the resin is something that's a hazardous material. So you always want to use some gloves, but you can see these supports are really interesting. They're made to build away from the part, so it cuts down on your post-processing time, and they just kind of break away. So after you break away all the supports, the next thing is you want to wash it off in some IPA so that you get all the uncured resin off the part. And what I mean is you just have a vat of IPA, and you wear some gloves and you wash off the part. The resin sometimes sticks to the part like molasses, and so the IPA helps dissolve the resin. Once the resin's all off the part, you put it in a final cure box for about 10 minutes on each side, and it cures your part, and then you're off to the races, and you can do whatever you need to do to your parts. Okay, so that is the software demo. I think it went pretty easy. I didn't even spend 15 minutes because there's not too much to do with software. It's really easy to use. Basically, you're just rotating the part around, building supports. If you don't like those supports, rotate it again, build some more supports, then slice it and send it to the printer. So the next thing is the next step. So let's say that you're interested in bringing something like this in the house, and you want to know, how do I go about doing that? So for that, we're going to have everything go through our account manager, Anthony Jean. I have his email and his phone number here. This will be recorded as well, so if you want to watch this and find this data, you could also just give our 1-800 number a call, and we can get you to the right person, and we can just start building a conversation on what material would work well for you, what printer, what size, you know, all the site requirements and that stuff. Okay, guys, I'm just about done here. So let's say that you're not ready to buy a printer, but you just want to learn more about 3D printing. So we have two things coming up in August. In Palo Alto, there's an HP Roadshow to show off their new printers. There's a 300 and 500 series. And then on August 10th, we're actually going to have a guest speaker in the Santa Clara office, and that's going to be Daniel Laser, and he's going to be talking about the new Metal X printer. Both of these are on our website, so if you want to register for either one, you can go to hawkridge.com/company/events, and you can register for either one of these. Okay, that's it, guys. Thank you for attending. I'm going to stick around for about another 5 minutes or so and answer any questions. So if you do have any questions, put them in the chat, and I'll try to answer them as I see them. This will also be recorded, so if you want to watch it later on, feel free. Thank you, guys, and have a great day.